Okay, so I will resume after the crash at the end of the previous video. I could not I could not I could not save that. I could not find. I had to redo it, everything. So I typed everything again from the scratch. So let me like go over all the algebra again. So remember, we we had to include instruments, even if we know it is useless in estimation, but we need it for testing, right? That's the idea of the testing. We are testing if the redundant moment condition is satisfied or not. Okay, so we revived it here. So, and the weighting matrix, we calculated the weighting matrix in the previous homework 4. I showed you weighting matrix should be can be like this. So we have the sample moment function, weighting matrix, and as a result, the estimator was like this, OLS. Okay, so OLS is the estimator, and the algebra is going wild, so we simplify them using the notation given in the homework. So head A x y is sample average of x y, like that. So the sample moment x times y is coming here, and x times beta x is coming here, beta still here, and xx. But the first moment will be 0 if beta is the OLS. So when you evaluate the beta at the minimum, then it will be 0. And the second one involves z, so it does not go away. So we still have something here. And the W requires inversion. We can do that 2 by 2 using the simple notation. You may write this as xx times zz minus xz squared, and zz here, xx here, and minus there. So combine all the things. Even though we simplify the notation, it's still pretty complicated, but fortunately having 0 here will save a lot of work, because of the 0, in the end we have this times the 2 by 2 2,2 element, right? In the end, there's a simple algebra, so you may try it by yourself. So in the end, we have this and coming here, and this times this is squared, right? And you simplify the algebra, then you are going to get the form in part H. Okay, okay, and remember, the correct J test is based on the difference, restricted criteria minus unrestricted criterion. But this, the unrestricted criterion was 0 in the minimum because there was only one moment function um, that is satisfied by one parameter. So we are going to have this, and we need standardization. We have to multiply something or do something to make it converge to the chi-square distribution. So we are going to do that in the later. But hint, like a spoiler, remember we had to have sigma squared here, right? But we deleted sigma squared because it did not matter in minimization, but it matters again in chi-square distribution, right? So for chi-square to have chi-square distribution, you have to revive that again, right? So sigma square must be adjusted for here. So we are going to see that pretty soon. Okay, just keep that in mind. And the next topic is Hausman test. Like if the null hypothesis was correct, then you know the OLS, uh, uh, the OLS will be similar to the IV estimator, right? That is the idea of Hausman test, like Hausman test. So, so our test statistic will be Hausman test. Let's say Hausman test will be n times minus oh, right. And under the null hypothesis, um, which converges in distribution to chi-square 1 under the null hypothesis. Okay. But again, the main problem is calculating the asymptotic variance. So we know that we already know that the variance, asymptotic variance of asymptotic variance is under the null hypothesis if H0 is correct, right? This is Hausman's theorem. But here in this case, like if we use this result, everything will be pretty simple because like U is like restricted estimator is OLS and this is IV regression estimator. So you know how to calculate the variances pretty simply, but we are going to just take the full approach. We will calculate the variance directly without using this theorem. So we will check if this is true, right? to do that, first rewrite the we will rewrite this as right. It was OLS and like this. So we are going to have this, and we want to find something like this converges to in distribution to normal V 0V. So this is what we want, like under the null hypothesis. By the way, you have to say under the null hypothesis here because, as I mentioned earlier, the mean is 0. I'm assuming that its mean is 0, so this will be 0 on average because the null hypothesis is correct. If null hypothesis was not true, then you have to have like it will be non-zero or you have to subtract something. There should be bias. Okay, so that's why I keep saying this here. Okay, then I described the basic ideas for 3 types of tests, right? Criterion-based test and like Watts test and Hausman test. And next, I'd like to show asymptotically everything is the same. All of them will converge to the same thing. Especially, I want to show this, right? And we had a very similar object from the wild test. Okay, so I think I need some preparation to revive the what I lost. So the most important lesson from this class is that you have to back up your documents. Okay, so crash can happen anytime, so be careful. Okay, I will continue in the next video. In the next video, I will discuss part A and B and the asymptotic distributions, and we'll conclude homework 5. Okay, see you there.